Welcome to my channel Learning Electronic Circuits. Here you can learn more about different electronic circuits, its working principles and the construction techniques. Today I am going to talk about the different terms in electronics such as electric charge, voltage and current. We are going to look at the definition of each of these terms, their properties and the unit of measurement. Electric charge. Electric charge is the property of matter showing an excess of charge of either positive or negative, which causes it to be either positively charged or negatively charged. An object that has an absence of charge is termed as neutral. An atom is made up of protons, neutrons and electrons. The protons and neutrons form the center of the atom, which is called as a nucleus. Protons are positively charged particles and the neutrons does not have any charge. The electrons are negatively charged particles and it revolves around the nucleus at specific distance called as orbitals. The electrons are arranged in different elliptical orbits or shells at varying distance from the nucleus that form a cloud surrounding it. The electrons rotate around the nucleus in all directions. The number of protons within the atomic nucleus is the atomic number of the element. It distinguishes one element from the other. Each element also has an atomic weight, which is the mass of the atom. It is determined by the total number of protons and neutrons in the nucleus. The number of negative electrons in the orbits and the number of positive protons in the atomic nucleus are the same. Thus, the atom is electrically neutral in the normal state. The protons and neutrons are tightly bound together within the atomic nucleus and they do not have any specific orbit. The electrons in the nearest orbit have the greatest force of attraction, whereas electrons in the distant orbits have the least force of attraction. The electrons in the outer orbits of the atom that are loosely held to the nucleus are called as the valence electrons. The loosely bound electrons in the outer shell of the atom can become free by application of energy such as heat. These free electrons move randomly throughout the space between the outer orbits of the nearby atoms. Such loose electrons are called as free electrons. When an atom loses an electron by the application of heat or energy, it becomes positively charged as it now has more protons than electrons. When the atom receives extra electrons from the nearby atoms, it becomes negatively charged. When an atom loses one or more electrons, it gives rise to a resultant positive charge called as a cation, but when it gains electrons, it becomes negatively charged called as an anion. Electric charge in a piece of matter is carried by the number of positively charged protons and the negatively charged electrons. When the valence shell of the atom has more free electrons, the better the conduction of current by the atom. This charge of the atom is measured for its electrical properties. The charge is standardized. It comes in as integer multiples of individual small units called elementary charge E. The charge of an electron is negative E, while that of a proton is positive E. The charge of one electron is noted as 1.602 into 10 raised to negative 19. The unit of charge is the coulomb, or C, named after the French physicist Charles-Augustin de Coulomb. 1 coulomb is the quantity of charge that passes through the cross-section of an electrical conductor carrying 1 ampere of current per second. 1 coulomb of charge is equal to 1 by 1.602 into 10 raised to negative 19 or 6.25 into 10 raised to 18 electrons. Electric potential or voltage. When like charges or similar charges such as a positive charge and another positive charge are brought together, they repel. Whereas a positive charge and a negative charge are brought together, they attract. A charged particle has the ability to do work. This ability of the charged particle to do work is called as electric potential. Two opposite charges have a difference in electric potential. When there is excess of electrons or negative charges at one end of the conductor and a deficiency of electrons or positive charge at the opposite end, an electric current passes between the two ends. The electric current flows through the conductor as long as the difference in potential exists between the two terminals. The source that creates an excess of electrons at one end and a deficiency at the other end is the potential source. Potential is the ability of the source to do electric work. The difference of potential that exists at both ends of the conductor causes the electron to flow in a circuit, which in turn accomplishes the work done in the circuit. This difference in potential is referred to as electromotive force, EMF or voltage. So the potential difference of voltage is the force that moves the electron from one end of the terminal to the other. Voltage or potential difference is the difference in electric potential between 2 points, which is defined as the work needed per unit of charge to move a test charge between 2 points. The unit for measuring voltage or potential difference is called as volt, or V, which is named after Alexander Volta. The symbol E is used to represent voltage. Work per unit is expressed as joules per coulomb. The electrical difference between 2 points can be caused by electric charge, electric current through a magnetic field, a time-varying magnetic field, or a combination of the above. Electric current. The flow of electric charge in the form of free electrons is called as an electric current. The charge is caused by moving electrons in a wire, movement of ions in an electrolyte, or by both ions and electrons as in plasma. Current is measured by the number of free electrons passing through a particular point per second in a circuit. Flow of charge per second is the amount of electric current. The SI unit for measuring an electric current is the ampere. 1 ampere is the current when the charge moves at the rate of 6.25 into 10 raised to 18 electrons flowing through a point in 1 second. Electric current is measured by an instrument known as an ammeter. There are two types of effects that are caused by the flow of electric current. One is Joule heating. It is the heat produced when the current flows through a conductor. Example, heating of the filament of an incandescent bulb, heating of the elements of an electric heater or kettle, heating in soldering and etc. To form magnetic fields. Magnetic fields are formed around a conductor when the current passes through it. Example, inductors, motors, generators, etc. The particles that carry the charge in an electric current are known as charge carriers. In solids, these charge carriers are electrons which are closely bound to the outer orbit of the atom. In liquids, the charge carriers are positive and negative ions. In plasma, the charge carriers are composed of both electrons and ions. In conductors such as metals, the positively charged atomic nuclei are held in a fixed position, and the negatively charged electrons are free to move about across atoms carrying the charge along with them. In semiconductor materials, the charge carriers can be both positive and negative, either electrons or holes. That depends on the type of semiconductor and its doping. In electrochemical cells, both positive and negative ions are present at the same time. The symbol for current I, which comes from the French phrase intensité de current, that means current intensity. It is simply referred to as current. The symbol I for current is used by Henri-Marie Ampère. The unit of electric current is named after the inventor who discovered it. Flow of charges produce the same effect in a circuit or similar flow of current if these changes are either positive or negative. The direction of conventional current flow is taken as the direction of flow of positive charge. As the current flows through a conductor or component in either direction, a variable is defined to support the direction of flow of current, which is denoted by a positive or negative number. There are two types of current. One, direct current. Two, alternating current. Direct current. Direct current is a unidirectional flow of electrons. Here the current flows only in one direction. The waveform for direct current is a straight line, but there are also pulse-mode waveforms. Direct current can flow through conductors, semiconductors, insulators, or even through vacuum. Direct current does not travel long distances without reduction in power due to wire resistance. The source of direct current are batteries, thermocouple, solar cells, etc. Alternating current. When the movement of electric charge reverses its direction periodically, it is called as an alternating current. The usual waveform of an alternating current is a sine wave. There are also other waveforms such as triangular waves, square waves, etc. used for various applications. The source of alternating current are generators, alternators, dynamos, etc. Alternating current travels long distances, thus it is used in power transmission. Audio, radio, digital waveforms also utilizes alternating current waveform characteristics.